How's everybody doing today? In this video, I'm going to discuss some of the elements of hypothesis testing. Hypothesis testing. Very valuable tool, especially in decision making. So that's why I'm going to use an example with decision making. Suppose your neighbors want to open up a pretzel business. Pretzel business. And they have some extra money that they have, and they want to use it for a pretzel business. But they don't want to invest in the business and not have any profit. So they have a claim, and their claim, which is be our hypothesis, our null hypothesis. They have a claim that the percentage of people that would buy their pretzels would be greater or equal to 40%. So 40% of, and let's say the population was very big. It's a very big town, 100,000 people. They believe, not only do they believe, but they have strong evidence that this would happen. So the null hypothesis would be less than 40%. And that would be bad. That would be something not good to open the business. So what do you think they do to investigate this? They get together some friends and they go out and knock on some doors randomly. They do a random sample. So they have a random sample of 40. So they're going to test their claim with a random sample. But as they're doing a random sample, they're also thinking about this hypothesis here. This hypothesis is 40. So they're not going after the whole population. They're just going to have some just a small sample. So there's going to be some error there. So there's going to be a distribution here. It'll be a normal distribution around 0.4. And when they collect their sample, it'll fall somewhere in this neighborhood here of 0.4. And we know from a prior lesson that the sampling distribution of a proportion with around 40 is a normal distribution. But their main concern is now, when do we reject this null hypothesis? And we reject, and this is the extreme negative value, which is that's their concern. It's a one-sided test. Let's go back and say, why did we choose 0.4 and not like 0.5? Because we're saying greater or equal to 0.4. Well, that's intuitive. It makes sense that we choose 0.4 because we've got 0.4, 0.5, 0.6, 0.7, all these numbers. But let's suppose we chose 0.5 and we rejected the null hypothesis at 0.5. Well, that doesn't mean we can reject it at 0.4. Because it might not be enough to reject at 0.4. So if we can reject at 0.4, we can reject all the other ones. So that's why we chose 0.4. Okay, so now we're looking at our area of rejection. This is our area of rejection in red here, right here. If that's that extreme, and then you get the probability of getting, let's say it's 10%. And again, it depends on everybody's threshold of how much error they want to take. And again, this is error. This is type 1 error. That's type 1 error. And if you fall in here, you're probably not in the null hype, from that distribution. But so you have a 10% chance of being in 0.4, but you're still going to reject. So you're going to make it what we call a type 1 error. But that's what we're willing to take on here. If we get a value all the way over here, we're willing it probably didn't come from here. Okay, so let's suppose 0.1 is our type 1 error. And because this is a sampling distribution, the standard error of this is equal to, standard error is 0.4 times 1 minus 0.4 all over 40, and the square root of that. So that's 0.4 times 0.6 over 40 square root. Get your calculators out. And that is 0.0776. 776. So that's our standard error. Now, we want to find the rejection region. So the region we want to find, we need to find a value here, x. What is that x? So that would be, again, from normal distribution theory, it's x, the z value is x minus 0.4 over the standard error. And again, let's get out our little tables. We know from our standard normal distribution that this value here should be equal to, let's get out the book, it is minus that value. Let's see, I'm looking in the book. It's also in Excel. That number is also in Excel. You can find that in Excel. And that happens to be coming out to be negative 1.28155. So we multiply these two numbers, add 0.4, get out our calculators again. X is equal to 0.3. So this is 0.3. Anything less than 0.3, we're going to reject that claim, that entire claim. So we're finishing up our sample now. Here we are. We're back here. Got a lot of neighbors working on it. You're all working hard. You had to go back to a couple houses because they just weren't home, and you didn't want any non-response error in there. You didn't want any non-response error. So anyway, just a big word of saying we just want to make sure we get everybody in our sample. So we get 40, and it turns out that 14 out of 40 said they would buy the pretzel. So that's 35%. So that's a good number. That's 35%. So 35% is what we get here. And we don't reject. We don't reject. We do not reject. Why? Because 0.35 is greater than 0.3. If it were less than 0.3, we would have rejected that claim and said, nope, we don't want to pursue this. And again, be careful because in my following videos I will address some other issues. So, here we don't reject, so we accept. But that doesn't mean we accept this null hypothesis. We don't know at this point. One other little thing is, have something called a p-value you might hear about in your readings or something when you're looking at some journal articles. 0.35, which is this number. If you put 0.35 here, it's right about here. That's 0.35. And if you look at the area from there or more extreme, which means worse, this is the bad area we're looking at. So this area here, what is that area? Well, that's again, we just plug in, here we know it's 0.35 minus 0.4 over 0.0776. I'm sorry, that's 0.35. And when you get your calculator out, solve for that, that's negative 0.645. And when you go back to your z-table, let's pull out our z-table. I've got my z-table right here. Standard z-table. And again, what I'm looking at with this z-table is this area. It's giving me this area here, and that's my z number. So that happens to be, that area happens to be, I'm looking at my z-table, it is let's see, what is it saying here? It's 0.26. So the area is 0.26. 0.26. So that's my p-value. 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 So I'm out of time. So in my next video. Hopefully this excites you to watch the next video. And we will talk more about hypothesis testing and decision-making concepts and show you why we need more information now, even though we accepted. I'll see you later.